day, students. How are you feeling today? That's good to hear. So, is anyone absent or excused for today? Very good. Perfect attendance. Before we move on to our new topic, let us have a short review of what we have discussed in the last meeting. Any volunteers from the class? Very good. We discussed about solid figures. Can someone give me examples of it? Very good, children. Okay, so we are now ready to tackle our first lesson for the fourth quarter. Before I formally start the lesson, I want everyone to pay attention because we are going to have a short game called Look Around. In this game, I want you to look at your surroundings and observe things that are circle in shape. I'll give you 2 minutes to look around. Okay, can someone share what he or she observed? Any examples of circular things that you saw? Coins, good example. What else? Clock, correct. Any other hands? Excellent, children. All of your answers are correct. There are indeed plenty of things that are circle in shape. What do you think is the connection of our game to our new lesson? Yes, very good. What else? Excellent. We are going to talk about the area of a circle. So let us now begin our discussion.
Before we begin, think of a time when you use something round, maybe a clock or a wheel. Have you ever wondered how we measured circle? Today, we'll learn exactly that. By the end of this lesson, you will be able to define the key term related to circles such as the radius, the circumference, the diameter, and the area. Demonstrate how to use the formulas for both routine and non-routine problem involving the area of a circle. Recognize the importance of applying this measurement in real-life situations. The discussion for today will be all about circle. But before we start, we should familiarize ourselves with circle. A circle is the only shape that has no corner or edge, and the angle of a circle can measure up to 360 degrees. Let me ask you a question. How can we measure a circle? Correct. A circle can be measured by its radius, diameter, and circumference. The diameter is the distance across the circle through the center point, and it's twice the radius. On the other hand, the radius is the distance from the center of a circle to any point on its circumference, and it is half the diameter. Circumference is the distance around the boundary of a circle.
When showing the slope of the circumference of the circle, we need to identify two values, the pi and the radius or diameter. The pi is a Greek letter pronounced pi, which is approximately equal to 3.14. Yes, it is constant in all circles. Yet if this is given, we can use the formula circumference is equivalent to 2 pi r to look for the circumference. But if a diameter is given, we should use circumference is equivalent to pi d as our formula. Does anyone know why we don't multiply diameter, just like what is done in the first formula? That is right. Always remember that 2 radius is equal to 1 diameter and a radius is half the diameter. For example, the radius of a circle is 15 meters. For us to find the circumference, what formula should we use? Correct answer. Now, we just need to multiply 15 by 2 and multiply it again to the pi. Just put the given to the formula. 2 times 3.14 times 15, and the circumference is equivalent to 94.2 meters. Remember that the diameter is twice the radius. So if the question is asking for the value of diameter, you simply multiply the radius by 2. So if the radius is 15 meters, 15 times 2 is the diameter is equivalent to 30 meters. Another example, the diameter of a circle is 15 meters. Using this, what formula should we use again? That would be correct. Since the value of diameter is given, we just need to multiply its value by its pi. Diameter is equivalent to 15 meters. So, circumference is equivalent to pi b. 3.14 times 15 is equivalent to 47.1 meter.
Now that we have identified the key measurements of a circle, we can now find its area. Remember that radius, diameter, and pi are important in calculating the area of a circle. As for the formula of the circle, the equation A equals pi r squared is used. Let's use a real-life situation for us to understand the equation better. Jim swam from the center of a circular pool to its edge, covering a distance of 9 meters. What is the area of a circular pool? After reading the problem, we should identify first what is given. Can you tell me what key measurement of the circle was stated in the problem? If yes, how can you say so? Correct. Since it was specifically stated that 9 meters was the distance across the circular pool through its center, we can conclude that the value given is the radius. Since the value of radius is given, we should directly substitute it to the formula. Again, what is the formula for the area of a circle? That's right. And the value of pi is 3.14, correct. Great, you have understood it well. So in order for you to master this lesson, you can pause the video and try answer the problem. Now, to answer the question, let's substitute all given values. A equals 3.14 times 9 squared. 9 squared is 81. And let's multiply it to 3.14 and we get the 254.34 meters squared. If your answer is 254.34, then you are definitely correct.
Let's have another problem, shall we? Carol is painting a large circle on the wall of his new apartment. The distance across the circle is 20 feet. How many square feet of the circle will be painted? Again, what key measurement is given in the problem? Yes, it's the diameter. And now, the formula will be correct. A equals pi r squared. But wait, there's no d in that formula. And we were given the diameter. So what do we do? Exactly, we divide the diameter by 2 to get the radius. So if d is 20 feet, let's divide it by 2. That gives us 10 feet for the radius. Now that we know the radius, let's solve for the area. Alright, I'll give you time to solve it. So what's the final answer? Alright, let's solve it together. So we use the formula first. A equals pi r squared. Now, let's substitute the values. A equals 3.14 times 10 times 10. So we multiply 10 by 10 first, and that gives us 100. And we multiply by 3.14 by 100, and we get 314 square feet. So, the total area Carol will paint is 314 square feet. Great job, everyone!
Now we'll be tackling how to measure area of a real object. Can you see this compass? Let's take this compass as our circle. To find the actual area of this compass, first we need to find its radius or diameter. By using a ruler, the diameter of this compass is found to be 10 inches. After doing this, what should we do? Which is good. Again, how do we measure the area of a circle? That is correct. Therefore, to get the area pi r squared, 3.14 times 5 inches times 5 inches. 3.14 times 25 inches squared. The area is 78.5 inches squared. After the substitution of values, we have identified the area of this compass, which is 78.5 square inches. After what we just did, do you all think that you can measure the area of all circular objects you see around? Well, that means you listen attentively for today's class.
To summarize today's lesson on the area of a circle, we have learned the key concepts of radius, diameter, and circumference. We tackled how to apply the formula for finding the area of a circle. Area is equal to A equals to pi r squared, in which pi is approximately 3.42, whereas circumference is equal to C is equals to 2 pi r if radius is given, or C equals to pi d if diameter is given. Always remember that the radius is half of a diameter, or diameter is twice the radius. Now, let's get into some practice problems. Let's calculate the area of a circle if the radius is 8 centimeters. I'll write this on our virtual whiteboard. Now, who can tell me the formula we'll use to solve this? That is right. We use the formula A equals to pi r squared. Now, who can tell me the value of pi? Okay, I see your answers here in the comment section, and you're all correct. What's the next thing we do? Excellent! Since 8 squared is equal to 64, now let's calculate it. Let's multiply 3.14 by 64. So the area is 200.96 centimeters squared. Well done.
Here are a few practice problems for you to solve. I'll call on 5 students to come up to the whiteboard or share their screen to solve them, while the rest of you will work on your own or in the chat or in a document. Take a few minutes to solve these problems. Type your answers in the chat or share a screen when you're ready. I'll give you feedback as we go along, but you first need to ask permission when you share your screen.
Very good, class. Now, let's make this more fun. I have some real-life circular object here with me. I'll start by measuring the diameter of this clock and show you how to use it to calculate the area and circumference. The diameter of this clock is 10 inches. So, what is the radius? You can type your answer in the chat. Exactly! The radius is half the diameter, so it's 5 inches. Let's now calculate the area of object using the formula. So, the circumference is 78.5 inches squared. Great job! Now class, let's use our imagination. I want each of you to think 3 real-life objects that are shaped like a circle. It could be anything. For each of the 3 objects, you have to find the radius, diameter, circumference, and area. You have 5 minutes to think about your object and calculate the radius, diameter, circumference, and area. You can type your answers in a chat or write them down in a shared document. Afterward, I'd love for a few of you to share your answers with the class. Okay, time's up. Let's go ahead and share what you came up with.
Okay class, try to answer some questions regarding to our lesson for today. I'll be sending your quiz through Google Forms and follow the instructions carefully. Just write your answers in the Google Forms and we'll all answer it next meeting. Before we call it a day, I want you guys to write a summary of your understandings of the parts like radius, diameter, circumference, and etc. The formulas used, and how to measure a circle. In addition to this, to assess whether you really understood our topic, answer these following questions. Make sure you write it in a clean sheet of paper. Thank you and let's call it a day. Bye-bye!